So just to go over a few examples from the homework, where it's asking us to find the limit of f of x as x approaches infinity. Technically, you can think of this as the limit of 10 over x as x approaches infinity minus the limit of 5 as x approaches infinity. It may be a little easier to see if you separate it out like that. Now, right here, I had you write down in class, if you're taking the limit of a rational function as x approaches infinity or positive or negative infinity, then use the horizontal asymptote. Well, you see right here the degree in the denominator is larger than the degree in the numerator, because really there's no variable in the numerator, right? So the horizontal asymptote would be y equals 0. Therefore, right there, the limit for that part is 0, because that's what the horizontal asymptote right there would be. Now here, the limit of 5 as x approaches infinity would just be the number 5. So basically what you're doing is saying 0 minus 5 equals negative 5. And so you would want to just plug that in for your answer, and you end up getting the same thing right here. If you plug in negative infinity, just think about, again, separate that limit. Now right here, I'm going to save us the burden of writing things out so many times and separating the limit out like we did in the last one, because once you've done that so many times, you kind of get the hint of what's going on. It's almost like direct substitution, where you can say this is just going to be see, if I said the limit of 2 as x approaches infinity, you get the number 2, and the limit of 13 as x approaches infinity, you get 13. Well, right here, as x approaches infinity, for 1 over x, it would go to 0 again, because it's sort of like the horizontal asymptote. So just know that anytime you have 1 over x and your x is approaching infinity, you just that goes to 0. Okay. So right here, our answer should just be 2 over 13, and it would be the same thing for negative infinity. Right here we ended up getting negative 2 plus, okay, now look, something over x as x approaches infinity, that goes to 0, okay? 6 minus something over x squared as x approaches, that goes to 0 as well, okay? So you end up getting negative 2 over 6, which equals negative 1/3. Okay, right here, rational function. You're plugging in x is approaching infinity. And this is just a normal looking rational function, so you think about the horizontal asymptote. And since the degree of the numerator is the same as the degree of the denominator, it's just 5 over 9. And it would be the same exact thing for negative infinity, because think about it. Negative 5 times infinity. Here, when you think about the horizontal asymptote, the horizontal asymptote would be y equals 0. So that's exactly what your limit as x approaches positive and negative infinity is. And here, the power of the numerator is the same as the denominator, so you're thinking about that 18 over 11, and you're just thinking about the horizontal asymptote, y equals 18 over 11, and it's the same exact thing for for positive and negative infinity. Here the denominator is the degree of the denominator is greater than the degree of the numerator. So you're getting 0, y equals 0 for the horizontal asymptote.